For our next transformation of functions, we're going to shift a function either left or right, and that's called a horizontal shift. So again, we'll let f be a function and let c be a positive number. The graph of, and let's deal with the first one first, not the ones in brackets. The graph of y equals f of x plus c is the graph of f of x, y equals f of x, shifted c units, which direction? Now this you'll need to memorize. Most students like to say, well, you're going to shift it right. But if you're adding a number here, a positive number, you're shifting it left. Kind of the opposite of what you might expect. And then if the graph of y equals f of x minus c, well, that shifts it to the right. So let's do a little example here. Okay, so this time our base function is going to be x squared. So let me go ahead and graph f of x equals x squared. Looks something like that. If you don't recall, I don't have graph paper here, but 0, 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. Okay, so what does this tell us? G of x is. Notice the only thing we did from f to g is we replaced x with x minus 3 in parentheses. Okay, so based upon what we just looked at, when you subtract, which way does it shift? It's going to shift it to the right 3 units. So 1, 2, 3. So it's just like sliding it over 3 units. So something like that. That would be G. And this one would be F. And now let's do H. Notice what H, instead of x squared, we replaced x with x plus 3, which means shift it to the left 3. 1, 2, 3. Oops, kind of wrote over my function f there. And this is going to be function h. And if you're not convinced that we did this correctly, let's just try something. We know that f of 0 is 0. So that gives us an ordered pair of 0, 0. That's this point right here. Well, now let's look at the function g. Where are we here? What's that point? This point is 3, 0. So it says if I plug in a 3, I should get a 0 out. Well, notice when you plug in a 3, let's see, g of 3 is 3 minus 3 squared, which is 0. So that means that 3, 0 would be a point on this graph. And likewise, if you plug in a negative 3 for x here, for h, negative 3 plus 3 gives us 0. So we've got this correct. Okay, let's review a little bit about what we've done so far. All right, here's a given function. We are not going to graph this function. This is kind of a weird one. It's got a square, x squared, it's got a radical x in it and a constant. All right, if the graph of g of x, a new function is obtained from this by shifting it up 3 units, then what is the function g of x? I want this shifted up 3 units. Well, shifted up is from the previous video. So what I want is to just add 3. I just want this, f of x. I want g of x to be equal to f of x plus 3. Remember, just tagging a number onto the end of it shifts it up 3. So this is going to be 3x squared plus radical x. I'm going to go ahead and write it as plus 1 plus 3, just so it's very obvious what we did. And really, this would be better written as 3x squared plus radical x plus 4. These two would have exactly the same shape, these graphs, exactly the same shape, but they would be located slightly differently. This one would be 3 units up from this one. All right, the second one. If the graph of h of x, a new function, is obtained from this function f, but we want to shift it left 3 units. How do we shift something left 3 units? Well, that means we take f of x, h of x would need to be f of x, what will it be for left, plus or minus 3? It's not minus, it's plus. It's the opposite of what you might think. So all that means we have to do is up here, replace that x right there, and replace this x right here with x plus 3. So 3 times x plus 3 in parentheses squared plus radical with x plus 3 underneath it plus 1. Simple as that. I'm not going to FOIL this out and multiply it by 3. I would, we'll leave it like this. Okay, last one in this video. If f of x equals x squared, we've seen that many times. We know what the graph looks like. We're not going to graph this one, but at least we're not asked to. I might go ahead and do it. If f of x equals x squared, then take a look at this graph, or this function. How is this graph going to be compared to the graph of f of x equals x squared? So, what do we have to do to this graph of f to get this? In other words, I guess, picture this graph. So let me go ahead and put what x squared looks like. That's the graph. What is this graph going to look like? And I'll give you a clue. The shape of the graph is going to be exactly the same as f. It's just located differently. Let's look at this first. X squared is replaced with x plus 2 squared. So the x is replaced with x plus 2. And then we tag on that minus 3, which remember what that is? That's a horizontal shift, 3 downward. This one says that's shifted left too. So obtained by doing what to the graph of f? Shift it left 2 and shift down 3. So really, all we need to do to get that graph is to take this, just take this point here. Go left 2 and down 3. And that point here gets transformed into this point, and we draw exactly the same shape here. So something like that.